Okay, fourth grade, this is lesson 610, Drawing and Measuring Angles, page 215. We will have to get a little creative today because my assumption is that you do not all have protractors on hand. Because again, this is not your typical household material these days. Not a lot of houses have protractors. This is one of those things when you're at school, we have protractors. So I'm going to get a little, I don't know if it's going to work, to be honest, but we'll find out. The good news is the first part of page 215, you don't need a protractor. And in fact, it tells you don't use one. That's going to come in later. So here they tell you to use a straight edge to draw the following angles. Do not use a protractor. Okay, so again, a straight edge, to review, is anything that is going to be straight, that allows you to draw a straight line. A ruler is a great straight edge. The beautiful thing about a protractor is that it has a straight edge that you can use, or you can just get creative. You could use sticky notes if you have them, or the side of a book, as long as you're careful not to get pencil onto the book. You can even use really anything. If you have security envelopes sitting around, that could work. Okay, anything that will allow you to make a reliable and straight line. I repeat, if possible, don't freehand this. Angles have to be exact, or we have to at least try to make them exact. So number one is telling us to use a straight edge to draw any angle that measures less than 90 degrees. Now, if you remember from lesson 6-9, we went over, I think, let me count from my notebook, 1, 2, 3, 4, 5 different types of angles. And one of them we've worked on all year, and that is an angle that measures less than 90. That is called an acute angle. So they want you to use a straight edge to draw an acute angle to begin. And I'll give you an example here. An acute angle is anything less than 90. My mechanical pencil is starting to do that thing where the lead goes up into the barrel. It's going to be annoying. This would be an example of an acute angle. I need to make sure my vertex exists down there. It's going to be less than 90 because remember, a 90-degree angle looks like a capital L. And not only is it 90 degrees, but we call that a right angle. So you want something that's going to look like an acute, because this is 90 degrees. And knowing this fact here is going to help you with number 2, which says draw any angle that measures more than 90, but less than 180. Okay, and any angle that's more than 90 and less than 180 is called an obtuse angle. So they want you to draw an obtuse angle. Now the third one is going to be hearkening back to our previous lesson when we introduced this guy. And a straight angle measures exactly 180 degrees. Boy, this lead is going to irritate me. So you may need to look back in your notes, or I can help you out. I'll put this on the screen real quick. There's an example of the straight angle. In fact, I'll put the rest on there too, just as a quick cheat sheet, so you can remember the different angles that we have introduced. So you should be set without a protractor for part 1. Here's where things will get interesting, part 2, because it's literally titled Measuring Angles with a Protractor. There's 2 steps here. They're going to want you to measure these angles and then identify what type of angle they are. So here was my creative thought. I'm going to try to look on the camera while I'm doing this to see if this would possibly work or not. I'm going to try to place my protractor exactly where it would go if I were measuring this. And then on screen, you might be able to tell, where is that second hand pointing? Remember, when we start from the right, we use the inside numbers. So use your best estimate, setting up your protractor. Where is he pointing? Okay, and for me, for that first one, it looks like he's awfully close to 60 degrees, maybe not quite there. I want you guys to go ahead and pause if you need to. Take a look at where he's at. In that case, you can get your measurement. If you have a protractor, use it. I want you to try to do it. But if you don't, hopefully this is a substitute. I'm going to keep going here, just so we don't zap up too much time. Our second angle I'm going to set up by putting the vertex right in this little middle hole. And now again, on screen, I want you guys to pause and see where is he pointed. And sometimes you have to extend him out or use your eyes to figure out where he's actually pointing. We're using the inside numbers for these first two. Okay, now here's the third one. Usually I need to flip the book so I can use my protractor as I see fit. Now, the thing here is we're going to have to go from the left-hand side. So do you remember how we were using the inside numbers when we were starting from the right? Well now, since we're starting from the left, and in fact it looks like... Actually, hey, we're in good shape. Just by switching the leg here, we can stay on the right side. This will still work. The problem I'm seeing is the numbers aren't showing up because of my desk. So let me try this too. Does that help? I hope so. Okay, vertex is located, line is here, so the rotation's going this way, which means we're going to start from 0 using your inside numbers, and I want you to estimate, where is he pointed? Which inside number is he pointed to going around? Okay, and that's going to be your measurement for angle 3, or as they call it, angle RTV. RTV. Okay, while I've got you, I'm going to flip over to 216 because it's more protractor work. So if I can here, this is going to be interesting too. 215, they actually want you to create your own angles using exact measurements. Sorry for the sound there, that's my lamp. It has one of those classic like pull strings, like it's dark and light. Anyway, they want you to draw an angle measuring 35 degrees to begin, using HG as one of its sides. So basically it looks like their vertex is going to be H, because I see an arrow pointed out here, meaning the first line is a ray that starts here and keeps going infinitely this direction. So we are actually going to start on the left hand side this time. So vertex right in the middle, black line, almost right about there. And so for this one, since we're starting from the opposite side, we're starting from the left, you're going to have to use the outside numbers. You notice how like this would be 0 degrees, so we need to find the one that's 0. We obviously wouldn't start at 170 or 180. So they want you to make a 35 degree angle, so you're going to want to follow this guy up until you hit 30, and 35 would be halfway between 30 and 40, which would be right about here. So I would want you guys to use a straight edge once you mark down in the estimated location. Use a straight edge to make that second ray. And he's going to go forever. That's what that arrow means. And we want you to name that side. Pick any letter you want. You can pick D for Dominic or E for Emily, whatever suits your fancy. J for James, G for Garrett, J for Jaden. It's all good. I'm going to pick R for Ryan. So that could be our 35-degree angle for number 1. All right, I'm going to speed through these next ones. I'm just going to basically place it and tell you what we're shooting for. Number 2, they want a 150-degree angle. So let me place. Make sure we're lined up as best as we can. And again, since vertex is here, arrow is to the left, we're using outside numbers. You're going to have to count up and find 150 degrees on the outside. And you have to make a mark on your paper, just an estimated area of where you think that would go. And you're going to use a straight edge to complete your angle. Yours are going to be closer to estimates because you don't have protractors, unless you do have a protractor, in which case it should be exact. But if you're just using my protractor as guidance, these are going to be rough. They're going to be rough of where they're going to end up. Okay, angle measuring 60 degrees. They're all starting from the left, so this is nice for us to get a nice change of pace here. So let me line up vertex and dot, and we're using the outside numbers because we're starting from the left side, and you're going to want to count up until you see 60. Mark it on your own paper. Look where it's at on my paper, and you're going to want to mark it around where it might be on yours. You should have a dot. And then what you're going to do is connect your vertex to your dot to find that second leg. Now last, I move some things around here. Going deep to number 4. They want a 15-degree angle. And we're going back to the right finally, so we get to go back to the way we are most familiar with. Vertex right in the middle. Black lines matched up. We're only going to 15, guys. So this is going to be a little complicated because here's 10 and here's 20. We're using the inside numbers for the right-hand side. 15 is going to end up actually right in the middle, which we can kind of estimate and come up. And do you see this line here? That's going to be our 15. So for the right-hand side, we're going to be right about there. Okay, again, I'm sorry. We know how it is here, guys. We're out of school, so you don't necessarily have all the materials you need, but hopefully you are able to get a grasp or a general idea of how we would use a protractor if you had one, and how you might be able to complete this assignment even without one. I'm going to say for the try this, considering our complications, I'm not going to insist that you do number 5. If you want to try it, you can. Just a reminder for you guys, a full circle is 360 degrees. They want 330. So can you imagine where that angle would end up? If that's too much to handle, that's fine. Hopefully you guys at least were able to get some of what we did up to this point. Okay, questions, comments, let me know. See you guys for the next lesson.